Draw the moment diagrams for the beam using method of superposition. Consider the beam to be simply supported. Assume A is a pin and B is a roller. To solve this, once again, we have to differentiate between different type of forces acting on this beam. So there's going to be three separate cases, one with the point load, one with distributed load, and another with the moment. Once we draw our free body diagram for each of the case, we can find our forces for each of the members for each of the case. In my case, I've found my value of the by taking moment about the point A, and then send the forces in y direction to find our value for A for each of the cases in all three scenarios or cases. Once you have that, now you can find your moment equations. For that, first of all, we need our load equation for case 1. Once you have the moment equation, you can find your shear equation by integrating the load equation. Once you have shear equation, you can take another integral and find the moment equation. And I've done that for scenario 1, and I'm going to do that for 1 and 2 as well. Once I have all the required moment equation, I can start drawing my moment diagram. But before that, I would have to sum my moment equations. In this case 1 is going to take the precedent because it has two separate regions. The other two don't. Now that I have required total moment equation, I can draw my moment equation or moment diagram, I meant. For the first 10 feet, I'm going to begin at positive 750. At 10 feet mark, I'm going to go up to 6875 mark. Going to be second order curve, continuing downwards. And when I reach my 20 feet mark, I'm going to use my second equation, which takes me all the way to 0. Curve again is going to be second order, concaving downwards. Now for the second half or second part of this problem, we have to consider that beam is cantilevered from the support at E. This means point B won't exist and A will become a fixed connection. This means there's going to be moment at each of the cases. Once we have our free body diagram for each of the cases, for case 1, I'm going to take moment about the point A. This will give me my moment at A. And then by summing the forces in y direction, I have my value for the AY. I'm going to repeat this step for case 1 and 2. One thing I forgot to mention that we needed to solve this problem is that we have to recognize that because there is this 750 moment on this beam, that means in the scenario or case 3, there is going to be force By. Because otherwise there is no way we can have this 750 pound per foot force on this beam, and that means we would have to find our reaction forces for this beam to solve this part of the problem. And this means what's going to happen is we have to find the value of the By, and to find the value of the By, we would have to take moment about the point A. In doing so, we're going to have 800 pounds 10 feet away, and then clockwise. And then we're going to clockwise 1000 pounds 10 feet away as well. Counterclockwise By 20 feet away. And plus our, or take away our 750 pound moment, all equals to 0. And solving for By, we get our solution as 3937.5 pounds. So that's the value we will need to use. And then another thing is the value of Ay, which in this case we still didn't know, but we do know the total moment that is going to act along this point at A, which is the total moment at, well, let's do that before we do anything else. So the total moment, well, we can find the Ay, which is simply sum of the forces in y direction before our whole beam. And this way, in this case, it's going to be 1800 take away the newly found force. So Ay is simply 862.5 pounds. And then the moment, if we take moment about the point A or B, it doesn't really matter. Our solution for our overall moment for case B is going to be 18,750. It's going to be clockwise. And to do that, I'm going to show that in our case 3 calculation at the moment. Once we have all the required forces, now we can find our moment equations. So for our first load, we're going to have our two separate regions like before. So we're going to have 0, 0 for each. One is going to be 0 to 10, the other one's 10 to 20. Once we have all the required moment equations, we can sum them to get our final solution, which is our moment diagram. So we're going to have two equations for two regions, just like before. Now that we have all the required moment equations, we can start drawing our moment equation. So I'm going to draw it on the same diagram as before. So for our initial value, it's going to start at 750 as well. And then for the halfway